Now we're going to start taking a closer look at radicals and radical functions and all the operations that are associated with them. So we should be pretty familiar with square roots, which is the inverse operation of squaring something, raising it to an exponent of 2. Now, when we take square roots, we have two different types of roots, a principal and a negative, and we denote the difference between the two of whether or not we have a positive or a negative sign or no negative sign in front of the radical. Some nomenclature to be familiar with is we have the radical sign, which is the sign that we use to indicate that we're taking a root. We have a square root, we have a cube root, we have a fourth root, and we can continue on with that. Now the number that's inside the radical sign is called the radicand. That's the expression that is being taken, that the root is being taken of. Now the index is the little number that goes here, and the index, default index is 2 for a square root, but if it's anything above a square root, then we'll indicate it with a different number there. The index will never be 1 because that is not a root. Now the reason we have two different roots, the principal root and then the negative square root, is because oftentimes when we square something, we have multiple values that when squared equal the same number. For example, 8 squared equals 64, and negative 8 squared also equals 64. So since both of these values square to the same thing, when we undo that operation, square rooting 64, we need a way to indicate whether it's positive or negative. Now, a lot of times when we are finding square roots, we can simplify either on our own, if it's a small enough perfect square that we're familiar with. If it's larger, we may need to use our calculator to evaluate the square root. So I'm going to go ahead and open up the calculator, and then let's take a look. Now, to make your life easier, you should be familiar with the first 12 sets of perfect squares. And so let's run through that list real quick. If I take 1 and square it, it equals 1. 2 squared is 4. 3 squared is 9. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. And 12 squared. You should be familiar with those, as it makes taking square roots much faster, and you will not have to rely on your calculator to quickly evaluate or simplify these expressions. Now, if you do need to use your calculator to take the square roots, here I have a TI-84. If you have a different model of calculator, then refer to the documentation for your calculator to make sure that you are comfortable with finding square roots as well as other types of roots. Now on the TI-84, we have this little blue button that's right above the x squared. And so since it's the blue label, we press the second key and then we press the x squared key, which gives us that square root. And now we can type in a value for the radicand. So we can put in any value for our square root and press enter to simplify it. Now we'll talk about in a little bit what happens when we don't have perfect squares. So we see the square root of 49 is 7. A number squared that equals 0 is just 0, so the square root of 0 is 0. Square root of 1 is 1. 1 times itself equals 1. 25 over 16. Well, the fraction 5 over 4, when squared, 5 squared and 4 squared equals 16. In order to get 0.36, we have to remember our decimal rules. When multiplying about the number of decimal places, 0.6 gives us our square root. Now, with variables, we have to consider, well, x raised to what power when squared equals x to the 8th? Well, we have to consider our power rules. Our power rule says we have to multiply the exponents when we take an exponent and raise it to an additional power. So what we're really looking at is what number times 2 equals 8? Well, that number would be 4. So the square root of x to the 8th is x to the 4th. A simple way to remember this is that we take the exponent and we divide it by whatever the index is. Here we have the square root of 16 for x to the 14th. And so we take the square root. Well, if I have 4x to the 7th and I square both of those, I get that radicand. Again, we did 14 divided by the index of 2 to get x to the 7th. And here we have a negative exponent, or sorry, a negative radical. So that means we'll take the square root of 4 and we get a negative 2. Now here we need to consider, well, what number squared equals negative 4? Well, our first indication might be 2. 2 squared equals 4, but not negative 4. Or we might consider negative 2. Well, negative 2 times itself, when we multiply two negatives together, that also gives us a 4. So neither 2 nor negative 2 work. And as a matter of fact, there is no real number that when squared equals negative 4. And so we have an imaginary number. For now, we'll refer to this as just non-real. We'll say that the solution is non-real. Much later in the chapter, we'll start to work with those complex numbers that are non-real. So we saw all of those were perfect squares, and they simplified to rational numbers. We had integers, we had whole numbers, we had fractions and decimals that were rational numbers. If we try to take the square root of something that's not a perfect square, then we're going to get an irrational number, like 7 and 10. So for example, over here on our calculator, if we take the square root of 7, 7's not a perfect square, so it gives us this decimal value. And the only reason it stops is because the calculator stops at a certain number of digits. If we try to convert it to a fraction, we see that, well, it can't convert it to a fraction because it is an irrational number. The same is true for the square root of 10, an irrational number. Now, as we saw with example I, the square root of a negative number is not going to be real. And then we only find the decimal approximations for irrational numbers using a calculator if it's specifically requested, which we will do later in this lesson. But if it's not requested, then we're not going to do it.